Buckle up, everyone, because today we are diving deep into the origins of the universe.
Pretty big topic.
Yeah, you could say that again. And to make things even more interesting, you've sent over a wild mix of sources for this deep dive.
Let's see, we've got encyclopedia entries,
Uh-huh.
some Wikipedia rabbit holes, a piece from a university website, and even a perspective from a Christian apologetics site.
It's going to be quite a ride.
It is going to be fascinating to trace how humanity's understanding of the cosmos has evolved over time.
Speaking of tracing things back to the beginning, those ancient creation myths totally blew me away.
Oh, yeah?
Like the Egyptian one with the
Yeah.
universe emerging from a primordial ocean.
It's a powerful image, isn't it?
It is. It's like a cosmic seed sprouting, and then there's the Greeks with chaos giving birth to everything. It really makes you think about how, even without the tools of modern science, people have always tried to make sense of where we came from.
Absolutely. These myths might not be scientifically accurate, but they offer a glimpse into the human psyche.
Our need to understand our place in the cosmos.
Exactly. And it's fascinating to see how these early cultures grappled with the same fundamental questions we still ask today.
Like, where did it all begin?
Right. And what is our purpose? Why are we here?
Big questions. But then we fast forward to the 20th century, and things start to get really interesting with Edwin Hubble and his discovery of the expanding universe.
Talk about a game changer.
Right. That discovery paved the way for the Big Bang Theory, didn't it?
It did. Hubble's observations were revolutionary. They shifted the paradigm from a static universe to one that's dynamic and evolving, a universe with a history.
A universe with a story, and that's where the Big Bang model comes in.
Precisely.
Okay, so the Big Bang, I always get tripped up on that idea of a singularity.
I can see why.
How can everything we know be squeezed into a single point?
It's a mind-boggling concept, for sure. Imagine all the matter and energy in the universe crammed into an incredibly hot, dense state, smaller than an atom.
Whoa!
That's the singularity. And then about 13.8 billion years ago, it all started expanding, rapidly cooling as it went. And over billions of years, this expansion led to the formation of galaxies, stars, planets, everything we see around us.
It's like the universe went from this tiny seed to this vast cosmic garden that we're all a part of. But there are some things about the Big Bang that don't quite add up right.
Like what?
Well, like the horizon problem. How can the universe be so uniform in temperature if parts of it were never in contact?
Ah, yes. It's like if you took 2 cups of coffee, one from Earth and one from a distant galaxy, and they were almost the same temperature, even though they've never been anywhere near each other.
Exactly. It's bizarre. And that's where the concept of cosmic inflation comes in, right?
You gotta imagine blowing up a balloon really fast. The dots you drew on it before inflating would spread apart rapidly.
Okay, I'm with you.
Inflation suggests that right after the Big Bang, the universe underwent an extremely rapid expansion, smoothing out any initial temperature variations.
So the universe hit fast forward on the expansion button.
You could say that
But wait, wouldn't that mean the early universe was incredibly chaotic? How did things settle down enough to form stars and galaxies?
that's where another mind-blowing concept comes in: quantum fluctuations.
Quantum fluctuations, okay.
These are tiny random energy fluctuations that happen at the subatomic level, a bit like ripples in a pond.
Gotcha.
During inflation, those tiny fluctuations got stretched out to cosmic proportions.
So those ripples become huge waves.
Exactly. And those stretched out fluctuations became the blueprint for the large-scale structure of the universe.
So areas where those fluctuations had higher energy density became galaxies and clusters of galaxies.
Precisely over billions of years, they attracted more and more matter, leading to the structures we observe today.
Okay, so we have the Big Bang inflation quantum fluctuations.
Mhm.
It's a lot to process, but it's pretty amazing how scientists have pieced together this story of the universe's early history.
It really is. It's a testament to the power of scientific inquiry.
But as with any good story, there are twists and turns, and one of those twists brings us to the controversial idea of intelligent design.
Ah, yes. Intelligent design, or ID.
This is where the conversation takes a turn from established science to a more debatable territory.
You could say that intelligent design argues that certain features of biological systems are simply too complex to have arisen through natural processes like evolution.
Like what kind of features?
Well, they point to things like the bacterial flagellum.
Okay.
It's a complex molecular machine, and they argue that it couldn't have evolved gradually because all of its parts are necessary for it to function.
So it's like a mousetrap.
Exactly. Take away one part and the whole thing stops working.
Yeah.
This is the idea of irreducible complexity.
But couldn't you argue that even a mousetrap could have started with simpler components that gradually evolved into a more complex structure over time?
That's a key criticism of ID. Critics argue that evolution often works by modifying existing structures, which can sometimes lead to seemingly imperfect solutions.
And they say that ID relies on arguments from ignorance.
Right. Basically, we can't explain it yet, therefore it must be designed.
And there was that court case, Kitzmiller v. Dover,
Oh yes, a landmark case.
where a judge ruled that intelligent design wasn't science and couldn't be taught in public school science classes.
That's right. The plaintiffs successfully argued that ID was essentially a form of creationism repackaged to avoid legal challenges.
They presented evidence that the term intelligent design had been inserted into a textbook to replace the word creationism.
Exactly. And the judge ultimately agreed that ID lacked scientific support and was rooted in religious beliefs violating the separation of church and state.
So we've got these ancient creation myths, the scientifically robust Big Bang theory, and then the more controversial idea of intelligent design.
Three very different perspectives on the origins of the universe.
It's like we've gone from ancient stories to a scientific model that explains a lot, but we still have these huge unknowns and different ways of interpreting them.
That's the beauty of exploring these big questions. We can trace the evolution of human thought, from those early attempts to find meaning in the cosmos to our modern scientific quest to understand its mechanics.
But the journey doesn't end there, does it?
Oh no, not at all. There are even bigger mysteries lurking out there in the vast expanse of space and time.
Okay, you've definitely piqued my curiosity. What other cosmic mysteries are we about to unravel in this deep dive?
Well, let's just say things are about to get even weirder. Are you ready to explore the mind-bending concept of the multiverse?
Multiple universes, really?
Really, it's an idea that really stretches the limits of our imagination.
Okay, I'm all ears. But before we get lost in other universes, let's talk about the one we know and love. You mentioned dark energy. What exactly is that, and why is it such a big deal?
Dark energy is a bit of a cosmic enigma. We know it exists because we see its effects. It's causing the universe to expand at an accelerating rate.
So it's like a mysterious force pushing everything apart?
Yeah, kind of like an anti-gravity.
Anti-gravity? That sounds like something straight out of science fiction.
It does, doesn't it? But here's the thing. We don't know what dark energy is or where it comes from. It makes up about 70% of the universe's total energy density, but we haven't been able to directly detect it or explain its properties.
So we know it's there, but we have no idea what it is. That's both exciting and kind of unsettling.
Exactly. And that's why dark energy is one of the biggest mysteries in cosmology today. It has huge implications for the fate of the universe.
Speaking of the fate of the universe, we've got to talk about the Big Rip and the Big Freeze. They both sound pretty bleak, to be honest. What's the difference, and is there any way to know which one is more likely?
Well, imagine the Big Rip as a cosmic explosion on a grand scale. If dark energy continues to increase in strength, it will eventually overpower even the fundamental forces holding matter together.
So galaxies would be torn apart?
Yes, followed by stars, planets, and even atoms themselves. It'd be the ultimate undo button for the universe.
Okay, I think I'd prefer the slow fade to black of the Big Freeze, but that still sounds pretty depressing. Everything just spreads out and gets colder and colder until nothing much happens anymore, right?
Exactly. Think of the Big Freeze as the universe running out of steam. Stars eventually burn out. New stars can't form, and eventually even black holes evaporate, leaving behind a vast, cold, and empty void.
So it's like the universe just gets bored and gives up no grand finale, just a slow, quiet fade into oblivion.
It's not a very exciting end, but it's one possibility. And as we were just discussing, the ultimate fate of the universe hinges on the nature of dark energy. If it remains constant, then the Big Freeze is the most likely scenario. But if dark energy increases in strength over time, then the Big Rip becomes a real possibility.
Okay, so we've got this mysterious force controlling the universe's destiny, and we're not even sure what it is. It's enough to make your head spin.
It is, but that's what makes cosmology so fascinating. We're constantly pushing the boundaries of our understanding, confronting these grand mysteries that challenge our assumptions about reality.
And speaking of challenging assumptions, let's dive into that mind-bending concept you mentioned earlier, the multiverse, multiple universes, really.
Really, it might sound like science fiction, but the idea of the multiverse emerges from several different areas of physics and cosmology, including inflationary cosmology and string theory.
All right, break it down for me. I remember you mentioned inflation earlier. How does that lead to multiple universes?
Well, think back to that balloon analogy. Some inflationary models suggest that inflation didn't end everywhere at the same time. Instead, different regions of space could have continued inflating, creating separate bubble universes.
So like a cosmic bubble bath, with each bubble being a different universe.
It's a wild concept,
Ugh.
and it gets even weirder when you consider string theory. This is a complex theoretical framework that attempts to unify all the fundamental forces of nature.
String theory, that's the one where everything is made of tiny vibrating strings, right? I vaguely remember trying to wrap my head around that in college.
That's the one, and one of the things that makes string theory so fascinating and also so challenging is that it allows for a vast number of possible solutions, each corresponding to a different universe with different physical laws and dimensions.
So according to string theory, our universe is just one possible configuration out of a mind-boggling number of possibilities. It's almost too much to comprehend.
It is mind-boggling, and it raises all sorts of questions about why our universe has this specific set of laws and constants that it does. Why are we in this universe and not some other one with completely different physics?
Which brings us back to that whole fine-tuning problem, right? Why does our universe seem so perfectly suited for life? Is it just a cosmic coincidence, or is there something more to it?
That's one of the big questions that the multiverse hypothesis tries to address. If there are countless universes with different properties, then it's statistically likely that at least one of them would end up with the right conditions for life to emerge. In other words, maybe we just got lucky.
We won the cosmic lottery. I like those odds. But if there are all these other universes out there, can we ever prove they exist, or is it just a fun thought experiment?
Proving the existence of the multiverse is a major challenge because, by definition, other universes would be causally disconnected from our own time. There's no way for us to directly observe or interact with them.
So we're stuck with the mystery, but even if we can't prove it, the idea of the multiverse really opens up a whole new way of thinking about the universe and our place within it.
Absolutely, and that's what makes exploring these big questions so rewarding. They challenge our assumptions and push us to consider possibilities that we might never have imagined otherwise.
Okay, so we've gone from the Big Bang to dark energy to the multiverse. We've talked about the universe is beginning its potential end, and now the possibility of other universes existing beyond our own. It's a lot to process, and it's incredible to think about how far our understanding of the universe has come.
It is, and yet there's still so much we don't know. Every answer seems to lead to more questions, which is what makes cosmology such a dynamic and exciting field of study.
Speaking of questions, I've got another one for you. We've talked a lot about the physical universe, its origins, and its evolution. But where does life fit into all of this? How did we go from stardust to sentient beings?
Yeah, it's a pretty amazing leap when you think about it, from the Big Bang to the emergence of life. From simple molecules to complex organisms, all shaped by the laws of physics and the forces of evolution. Where do we even begin to unpack that?
Well, we can start by acknowledging that the story of life is intimately intertwined with the story of the universe itself. The very atoms that make up our bodies were forged in the hearts of stars scattered across the cosmos in supernova explosions and eventually coalesced into the planet we call home.
So we really are stardust. I've always loved that idea, but how did those stardust atoms assemble themselves into something as complex and wondrous as life? It seems like such a giant leap from inanimate matter to living, breathing organisms.
It is a remarkable transition, and while we don't have all the answers, scientists are piecing together a fascinating picture of how life might have emerged. It all starts with the right ingredients, the building blocks of life. You're talking about things like amino acids and those other complex molecules that make up DNA and proteins. Where did those come from?
Interestingly, many of these building blocks have been found in meteorites and comets.
Really?
Yeah, suggesting they were already present in the early solar system.
So the seeds of life were delivered to Earth from space. That's an incredible thought. But how did those ingredients come together to form the first living organisms? I've heard about the primordial soup idea. Was it really as simple as that?
The primordial soup hypothesis is a classic one. It's based on the idea that early Earth's conditions, volcanic activity, lightning, and a mix of chemicals in the oceans, provided the perfect environment for those building blocks to assemble into more complex molecules.
So it's like a giant cosmic cooking pot simmering away for millions of years until voila, life.
It's a compelling image, but scientists are also exploring other possibilities, like the idea that life might have originated in hydrothermal vents, those hot springs on the ocean floor.
Hydrothermal vents, that sounds pretty intense. How could anything survive in those extreme environments?
They are extreme, but those conditions might have actually been ideal for the formation of the first organic molecules, and they provide a continuous source of chemical energy which could have fueled early life.
So instead of a primordial soup, we have a primordial hot tub. Either way. It's amazing to think about those early life forms, single-celled organisms clinging to existence in a world vastly different from our own.
It is. And it's from those humble beginnings that the incredible diversity of life we see today evolved over billions of years. Natural selection acted on variations within populations, favoring traits that increased an organism's chances of survival and reproduction.
Survival of the fittest, good old Darwin. It's amazing to think about those small, incremental changes adding up over vast stretches of time to create all the different species that have ever lived.
It's a testament to the power of evolution, and it connects us back to the very beginning, to that singularity where it all started. We're all part of this grand cosmic story, a story that's still unfolding.
It's truly a humbling thought. Okay, so we've covered a lot of ground today, from creation myths to the Big Bang, from cosmic inflation to the multiverse, from dark energy to the emergence of life on Earth. What a journey. But as we wrap up this deep dive, there's one final concept I want to make sure we touch on. It's something called the Anthropic Principle, and it relates to that whole idea of the universe being fine-tuned for life.
Ah, yes, the Anthropic Principle. It's a philosophical concept that tries to make sense of the apparent fine-tuning of the universe for life. The idea is that if any of the fundamental constants of physics were even slightly different, life as we know it wouldn't exist.
It's like we won the cosmic lottery, right? But the Anthropic Principle goes beyond that, doesn't it? It suggests that the universe is somehow compelled to give rise to life and consciousness.
That's one interpretation known as the strong Anthropic Principle. But it's much more controversial than the weak Anthropic Principle, which simply states that we shouldn't be surprised to find ourselves in a universe that's hospitable to life after all. If it weren't, we wouldn't be here to wonder about it.
So the strong Anthropic Principle is more about purpose, about the universe having some kind of inherent drive towards creating observers.
Exactly. It's a fascinating idea, but it's difficult to test scientifically and often leads to philosophical debates about the nature of the universe and its purpose.
So it's more of a philosophical musing than a scientific theory.
In many ways, yes. But it does raise some profound questions about our place in the cosmos. Is our existence simply a cosmic coincidence? Or is there something more to it? Is the universe somehow aware of us?
Whoa! It's a mind-blowing concept, and it definitely leaves me with more questions than answers. But isn't that the beauty of it all? The universe is this vast, mysterious, and endlessly fascinating place, and we're just beginning to scratch the surface of its secrets.
Absolutely. And that sense of wonder and curiosity is what drives us to keep exploring, to keep pushing the boundaries of knowledge and understanding.
Well said. And on that note, I think it's time to wrap up this deep dive into the origins of the universe and the emergence of life. It's been an incredible journey, and I want to thank you for being our expert guide through these cosmic landscapes.
It's been a pleasure sharing this exploration with you. And remember, the journey doesn't end here every time you look up at the stars. You're looking back in time, witnessing the grand unfolding of the universe's story. Keep exploring, keep asking questions, and keep that sense of wonder alive.
Couldn't have said it better myself. To all our listeners out there, thanks for joining us on this epic adventure. Until next time, keep those cosmic questions coming.